Hello and greetings from Wisconsin. My name is Brian Foote, and today we're going to talk about JavaScript and some of the constructs and considerations about using collections when you're using JavaScript. We're in the heart of Wisconsin on the east side, and last week we did get 31 inches of snow. Yes, I said 31 inches of snow. And that all that does is make it a great opportunity to do some coding and spend some time in an office working on assignments for our class. So let's talk about collections, all right? Collections are you have to understand that the difference between collections and entities. Entities are a particular object that may be stored, and then a collection is a group of those particular things. Let's just take, for an example, the idea of a car. A car is one entity. It has a lot of properties and methods, a lot of things that you can do to it. And then if we put those together in a lot of them, like all the cars in a parking lot, we have a collection of them where we can modify them or pass them or communicate those to different particular structures in different applications, and that's where the things really come into play. So here I've got a little bit of a presentation on some of the different aspects about collections in our environment here. Structured collections can provide access to data, and they're a critical component that can use in just about any JavaScript program, regardless of language. It's very important. And with the ES6, we've got a lot of things that can help us do these things better and more efficiently. All right, so we're going to talk a little bit about some components and some ideas that really pertain to that idea of collections. Ooh, hello, we're way in the wrong spot here. Let's jump back over to type arrays. Type arrays have an idea that you can create a collection of binary data or array-like data that is stored in a structure, and that can be accessed through an 8-byte or a 16-byte integer type way. But the problem with that is when you create the idea of a collection of information, you don't have access to that if you're doing it from the perspective of an array buffer. Let's take a look at some code with that. We've got an array buffer here that we created in a particular size. The size is 32. We checked that back when we got a size of 32, but we can't take a look at, we don't have access to that particular data. And it's a very important situation that we have to remedy. So how do we fix that? We create an abstraction, which is called a view, that we can throw that buffer to that particular view, and then we can get access to that view. We're going to see some more examples of this as we move along. I'm not going to dawdle with that because we've only got 10 minutes to really talk about this. So let's move along here. And then one of the exciting things or more interesting topics that I was talking about and found in this project was the endianness. Now, endianness is a big, long word that I hadn't had a whole lot of experience with, and I'm guessing many of us really didn't. So I thought I'd just spend a little bit of time talking about what that really means. Now, I was very familiar with the ideas of byte order, and that is kind of what this is, if you're familiar with that term. Otherwise, all it means is it refers to the sequential order in which bytes are arranged in a particular operating system. So why this is important in JavaScript is we're talking about JavaScript is over the web, right? And so JavaScript talks to different things on the web. And so we're concerned about the fact that a system that is remote may have a big endianness, meaning that it orders it in a certain way. And I don't want to spend a ton of time on what that really means because we're short time. But it may be, the problem comes because we have one system that's different, a big endian, compared to where we are, perhaps, is a little endian. Or the other way, we're on a big endian system and we're communicating information to a little endian. When we're talking about binary or hex information, that becomes problematic and matter of fact erroneous if we can do that, because we may be sending a piece of information over the wire to a different endian system, and it may interpret that as a totally different number. That is a huge problem. Okay, so let's take a little bit of we got some definitions here. I'm not going to read them all to you, but the big endian and little endian just basically mean they ordered them a little differently, and there are advantages to doing that. So there is a method to the madness when you do that. When we talk about though Indianness, I did a little bit of research and I found this link. And this link, I'm not going to play it for you, but the student that did it did a really nice job of very simply explaining, just on a whiteboard, what a lot of this Indianness really pertains to. So I recommend you take a look at that link and read up on what that is. The rest of this Prezi really talks about the ideas of different collections. Okay, we've got multiple views. What that really boils down to, if I click on the multiple views and look at the code, is I've got some 18 byte arrays that I'm making and some 16-bit that I'm making. And things become very easy to talk to, but we can flip them and become very bad. Now, what does this graphic really boil down to? Well, what I'm doing is on this line right here, I'm setting this value to 3085. Okay, it's an integer value. Now, if we're not careful, we get down in this area, we may flip-flop them the other way, and the 8-bit, 8-byte spot might be flipped with an 8-bit spot, and we might get back a different value. So if we flip-flop them, and be careful with that, and we can see more examples of this, we could possibly switch those values. So this is really a big discussion about different system. My biggest question when I was looking at a lot of this information was, frankly, why do I care? Okay, I care because these systems may be talking to different systems that are with different Indianness, and that is really what I really want to, send home with you, is the idea that it may be a different system. If it's the same system, it should not be a problem. Okay, moving on. All right, and that's just more information on splitting those pieces of information up. Okay. Now, maps and map values, map keys, weak maps, these are all different things that really boil down to the same idea, and that is that you are containing different entities in different sets. Okay, so let's just take a look at some of the map stuff. We've got you have a lot of experience here. You really understand the idea of key value, and you see that idea of key value all over the place from the perspective of collection values. And when we have it here, there's a number of code examples when we're talking about key values and how those are really stored when we're doing with maps and sets and other things like that. So if I take a look at the key example here, I'm really jamming a couple of things into this X variable here that's containing a number of values. It's basically an X and a Y. And we've got this same sort of thing that's really popping into that particular perspective. Okay? And as we move along here, we see some other examples of declaring keys and values and putting those particular things in. And it really comes down to the idea of being able to access those collections later in our program structure, so we can get back to those and utilize them in a perfect thing. So why do we care? Why do we care about collection values? Why don't I just why don't I just create all kinds of singleton values or entity values? Well, we might want to send information to a different spot, either in our program or a different program or in a different platform. So what you want to do is you want to have that ability to send those things in a relatively efficient piece of code that doesn't, we're not doing one, or let's say we had 50 different entities. I don't want to send all 50 of those. I want to send 50 of those in a group or some sort of a collection where I have all those pieces of information. All right. Moving on, in the interest of time, got a few other informations here. Oops. That was important because what we have here, ES6 allows us to do easier coding. That's what one of the takeaways is with this. We've got the set, we've got the get, which is really allowing us to do a little bit more concise code, which makes it a little more, hopefully, a little more understandable. Okay, we'll do that. And then this is just an example of a delete. We do two sets where we have two things put into that M array or data structure, and then we're deleting from that data structure. Same idea, a couple other methods of access. We've got a clear method, and we've got a size property. Okay, so we've added those two things in. We get the size back. We've got a 2, because we put the two things in, and then we cleared them out, which means we erase them all, and then we have a size of 0. So just like an example of some nice things there. Mapping ES6 makes this very nice to do some very direct mapping. Now, the problem with a lot of what we do in our programming world is we have to take information from one structure and put it into another structure. Well, we've got these new structure ideas that allow us to do that. Basically, they're mapping ideas. So they allow us to take one structure either through entries, or just the objects themselves, and jam them into a separate thing, which is just based on basically a copy of those particular things. A very some handy functionality. Map values do the same sort of thing, but we still have the idea of jamming values in instead of just a property by property thing, which is a little bit painful. Okay, map keys allow for the same sort of thing. What we have there is some ideas of how do I get that one value back from a whole bunch of things. So let's say let's just use states for an example. We've got one entry in the collection for every state. How do I get back to them? I can refer to them through the keys object that allows us to take a look at those particular things. More importantly, we've got the does it exist idea, and we have the has operator or method, which allows us to pass an entry into that particular object and allows us to check, hey, is it in the group or not? Going back to our car analogy, if we have a car in the parking lot or in our group, is my car out there? Gosh, you hope so, right? That type of idea. Okay. Moving along, then we've got a couple other things. Weak maps, which has some nice things about it, very similar to the mapping idea. Okay. And then we also have sets. Now, sets are interesting to me because I'm not used to this I have a lot of background in the Microsoft perspective. And the sets are interesting because it doesn't, what's the way they word here? It says a collection of unique values. Great. Duplicates are ignored. That's interesting to me because let's say I have a group of states and I have Wisconsin in that group of all the 50 states, and I try to add Wisconsin back in again. If Wisconsin is in there, it's going to just ignore it, which is really nice because sometimes as a programmer, you make that problem or you make that mistake and you add things back in again. We have a code creation example. I'm going to put things in here. Keep add. One of these is a duplicate. We're just going to put it in there. And then we have using a constructor, same sort of functionality, but we have a new set passing in these particular objects. Can be a very handy piece of information. And an accessor that allows us to get back into one of those particular things. Does it have that particular value in there? And you see that is actually familiar from the mapping perspective that we talked about a couple slides ago. Weak sets are very similar to weak maps. They hold objects instead of values. So you can take a look at those kind of structures and see if that fits your particular need. What we have down here is basically a lot of ES6 stuff, and some of this came out of ES5, but it's really been redefined in ES6. It defines a number of useful collections that make working with data in structural ways more efficient and effective, and I'm going to add actually more readable, because that's my biggest problem with some of these languages I have limited familiarity with. It's like, oh, I have no idea what the heck that's actually doing. But this does a much better job of allowing me to understand at a low level what's really happening. Okay, we've got these views that sit, type arrays that sit on top of views. We've got maps that are key values, and we got maps and sets that really help us with those particular things. Okay, so I've got that. If you have any questions, I definitely encourage you to give me a holler, and we can talk about what we have with JavaScript collections. Thank you very much. Have a super day.